Hi, my name is Arman Tavakoli. Um, my project is about an infrared receiver. It's very similar to the kind of receivers that you have in your TV. And this is a TV remote control. And what it does is that it receives signals and it decides what kind of signal it is and accordingly does something. So I programmed it to understand three of these keys that select colors and the volume keys that adjust the brightness. I'll demo it to you to see how it works, and I'll explain more about the details of how the circuitry work. And the title of this project is the infrared receiver. So as you can see, I'm pressing 2, it goes green. I press 3, it goes red, and I can adjust the brightness of it. So that means it has no brightness. I can go to full brightness, and if I change color, then I can still change brightness. And that cover is not there just for the looks of it. This is the strong LED, so if you lift it up, it might hurt your eye. Can do a test, but okay. So that's about it for what the circuitry does. Let me show you on the board how this thing works. When I press one of these keys, this remote control sends a list of pulses. It has about 67 different pulses in it. So it's something like this. It goes down, it does lots of small ones, does another big one, and keeps going. And there are about 67 of these. And for different keys, there are different combinations. So my job is to receive this, decide which one it is, and do something accordingly. And the way I'm doing that is there's a photodiode here. The photodiode is sensitive to what this guy is sending. So that tells me what's coming in. Then I count. The number of these pulses and how many of them have which beat. So you can divide them into two categories: the small ones and the bigger ones. Then you can, and there's like some exceptions at the beginning that don't fit into either category. So there's a super big one at first. Then there's a small b, and there's a small. Then there's a, so in this case there's a b, small, b, small, b, small, and it keeps going on. Something like that. And that, for example, could be for channel 1. For a different channel, you can have perhaps there's a big B and there's S, S, B, S. And then you can tell they're different. But in the actual signal, different channels have a lot of commonality. And it's about a third of the code is similar and the other third is different. And that's that. And the other thing to note is about setting the brightness. I'm using the pulse width modulation technique that we did for one of our labs. One issue to keep in mind is that the clock, the output of the clock is built into one of the pins of the microcontroller. So if I want to set the brightness of 3 different LEDs, I can't do it at the same time. I have to do it one at a time. That's because I can't tell the clock to go to a different pin. It's hardwired in it. So you have to come up with a novel idea for controlling 3 different LEDs. Is that we have a multiplexer, and there are 3 LEDs: LED1, LED2, LED3, and I have this modulation coming in here, and I want to decide which one of these 3 I'm going to send it to. Something like that. So I have these 2 keys here, and depending on what values I set here, these outputs goes to either one of these. And the multiplexer that we use in our lab, the first one, doesn't have an input for something like this. You can't tell it take this input and to take it to either of 3. But it has one that's called strobe. That when the strobe changes, it looks at these 2 and decides which one it's going to send it to. Luckily, it turns out that when you change the strobe, the value of these outputs also change. So I hooked up my pulse width modulation to the strobe. So my strobe is going up and down, and the output of these are also going up and down, one at a time. That's one subtle thing to notice. And the other thing to keep in mind, which is one of my favorite things of all time, is how do I set the brightness of the LED using pulse width modulation when you need lots of current. In this case, we're using transistors, and the way it works is that I have this signal coming in, and this is like that. It's like a square wave. And I have an LED that needs lots of power. The way you can control it is by a transistor. So you put the way we are hooking it up is you have, I think, 5 volts up here. There's the LED. That's the LED. I don't know what's the actual symbol for it. Something like this.
Like the regular diode with a little arrow coming out of it.
So that's the LED symbol. Don't get too philosophical about it. And then you put the transistor here. It has a funky shape, like a circle. Then you go to ground. And you need a transistor, you need a resistor here. So anyway, the circuitry is not important. What's really cool is that the transistor acts as a gate. So as this signal is going up and down, when it's up or when it's down, it acts as you're closing or opening the circuit. So when it's open is that you have a complete circuit. When it's closed, you have an incomplete circuit. So the amount of time that this is closed or open dictates how much of the time is LED on or off. And this is what changes the brightness. And that's the end of my presentation.
Thank you. Question.